Just to repeat for everybody who's in the webinar, we will be starting fairly soon, just allowing a couple more minutes for last minute stragglers to join us. Thank you. So just a couple more minutes and we will be starting. If I could just remind everybody to mute themselves, please. Thank you. Okay, well, hello everybody. I think we now have a reasonable number of people who have managed to come into the room, and I believe we now have all of our speakers. So I think we'll make a start to the webinar. If I could just remind everybody, simple housekeeping, could you please mute your microphones and don't go onto camera for the whole webinar. There will be a discussion session at the end where I think we can possibly allow some back and forth, but I'll let you know when that happens. So we'll get started. What I'd like to do first of all is welcome you all, and just very quickly, if you don't mind, for those of you who don't know, tell you a tiny bit about TRL. This slide here explains a bit about who we are and what we're about. We're an independent research transport research company, and our mission, as you can see on this slide, is to create clean, efficient transport that is safe, reliable and accessible for everyone. Now, clearly, safe and sustainable bus travel must play a role in achieving this mission, and the webinar today is really all about that. So if we look at the three challenges that we're going to talk about today: pathogens, particulates and passengers. Obviously a bit of alliteration there, but the title maps to what we see as three high-level challenges currently faced by the bus sector. The first one, unsurprisingly, is COVID. So I think it's an understatement to say, even to say, that this has flipped the industry on its head. Buses used to be the obvious solution to the mass movement of people in cities, and overnight they've become almost the least attractive option because of the impact of the pandemic. So two speakers from TRL, Alex Edwards and Kieran Ellis, will talk through some projects that we've been doing looking at that particular challenge area. The second challenge area is environmental sustainability. The need to decarbonise transport, of course, is the biggest long-term challenge we face, and air quality comes into this as well when we're thinking about public health. So we'll have some talks from Doros Nicolaides from TRL in that section. And then finally, the third challenge is all about demand. With new mobility, mobility as a service, and the wider active travel agenda all changing how transport is consumed, keeping passengers served and giving them what they need is going to be critical. We'll have three speakers in this section. Leslie Nootboom from Humanising Autonomy is a guest speaker, and then Ali Cooper and Boris Butt from TRL will also present in that section. So the format is very simple, very short 5-minute presentations. In each presentation, speakers will present a sort of specific challenge under that heading and some solutions and proposed next steps from the projects that they talk about. There will be time for discussion at the end, and what we'd like you to do, please, is if you have any questions that you'd like to set to any of the speakers, put them in the chat in Teams, or if you prefer, email them to aedwards@trl.co.uk, the email address on this slide. And what we'll do is we'll try and curate those questions and deal with some of them at the end. And as I said, we'd like this to be, certainly at the end when we are answering questions, we'd like that to be interactive if needed. So if you do want to actually speak as part of that discussion, can I ask you to raise your electronic hand to do so, and I'll manage people, bringing people into the discussion as that happens. Okay, so with that in mind, I think we're ready to start. So what I'll do now is I'll hand over to our first speaker, and that is Alex. Alex, over to you.
Hello. I think
you just need to put your camera on, Alex, that's all.
Yeah, I'm pressing that. Can you hear me?
We can hear you, yeah.
Okay, so you can live without a camera. That's not too bad. I don't know why that's turned off. So yeah, my focus has been on how to physically protect the bus drivers from the risk of virus transmission. This was some work that came up with TfL earlier this year, as you can imagine. If you want to go to the next one, please, Sean. The goal really has been to focus on having fresh air passing to the drivers and really good cleaning regimes, and that's all as per the government advice. But obviously drivers are on buses for much longer than passengers, and they are, potentially at a greater risk there because of the duration of time they spend on the vehicle. So there was a collaborative group set up, and that was between Transport for London and UCL and ourselves, TRL. And we've focused on the airflow modelling. So one of the features of London buses is that they have assault screens, and they are designed to protect drivers from physical attacks. The question was whether that could be adapted to better protect and extend the protection, if you like, to protect against the virus as well. So UCL have provided some expert input here, and they've done the airflow modelling part. You can see on the left, the image there is showing the assault screen, and you can see at the top corner, there's some gaps around it. On the right, that's the gaps have been sealed up with additional panels. So the London operators were working on how to do that in practicality and have been amazing in making those conversions. UCL were then able to use that as one of the variables to look at in the airflow modelling, and also about different combination of doors that were in use, the front or the middle door, whether the speech holes in the screens were open or shut, whether the cab window was open or shut, and the position of the driver. So there was a number of variables being used. The modelling covered essentially when the passenger breathes out, the air at their mouth was treated at 100% concentration, if you like, if you assume the worst case. So we don't know what is the dose of a virus, the virus that causes actual infection. So we just assumed worst case and looked at what happens to that passenger's breath as it spreads around the bus. So if it's 100% at the mouth concentration, then it would be obviously diluted by being mixed in amongst the rest of the air through the bus. So they've modelled the concentration levels as it spreads and the velocities of the air as it spreads. Next one, please, Sean. So essentially, by working through a series of comparative models, then UCL were able to show that the transmission of the air through from the passenger saloon could be reduced by over 90% in terms of what was getting through into the driver cab. So then that was achieved by having the right combination of doors in use, so the front and middle doors in use, by sealing up the gaps around the assault screen so that there was no gap greater than 5 millimeters, by sealing up the speech holes, and most importantly, by having the cab window open and in use wherever the drivers were safe to do so, and having that positive air coming in from the outside and obviously the ventilation systems within the cab. That was what was causing the air to not be transmitted through into the cab. The recommendations that went out to the bus operating companies also included converting the air circulation systems so that it was only taking fresh air, and obviously reiterated the need for cleaning regimes and having the cab window open as well. So our role, TRL's role, most importantly, what then was to compile that information and build it into TfL's specification so that operators knew how to convert the buses, and to write that into the specification for future buses so that all new buses used on the London fleet would be having this level of protection, which is essentially converting the assault screen into more of a virus screen as well. And I was, really interested to be involved in this project, and I'm really hopeful that it will help to protect our bus drivers in the future. That's me done, Sean. Thank you.
Thanks very much, Alex. So what I'd like to do now is introduce our next speaker, and that's Dr. Kieran Ellis, and she's going to talk to us about a second topic within this area. Over to you, Kieran.
Thanks, Sean. So hopefully my sound and everything's working. So I'm here to talk to you about a trial that TRL ran for TfL this summer, looking at setting up temperature testing within London bus garages. So obviously reducing transmission of COVID-19 is a key driver for everyone across the UK at the moment. And many workplaces are setting up temperature testing as a way of reducing the number of symptomatic COVID-19 sufferers within the workforce and potentially reducing transmission. What's less common is a systematic approach to data collection, which means tracking how cases develop and potentially with the potential of being able to assess how effective and how accurate temperature testing is at actually detecting COVID-19 cases. This is what we wanted to set up within the trial, and also to look at some of the operational challenges of setting up temperature testing. Next slide, please, Sean. So what we actually did, there were 10 operators involved. Throughout the entire trial period, there were we met up with representatives from the 10 operators, also from Unite, TRL and TfL, as a working group to discuss any challenges. There were 6 bus garages involved who set up temperature testing, so either using thermal cameras or handheld devices. And there were 4 garages who just followed normal reporting procedures, but who delivered some data back into the trial. Within the garages undertaking temperature testing, around 56,000 temperature checks were undertaken. And just to mention the full statistics, there were 4,000 drivers, almost 4,000 drivers involved, and covering 100,000 driver shifts, or almost that. So it's a huge effort from everyone involved. In terms of the temperature testing, the vast majority of temperatures, far higher than 99%, came back within a normal temperature range. 6, the drivers did have a high temperature which persisted over a 5-minute period. Those drivers were asked to return home and obtain a swab test. Of those drivers, no drivers returned a positive swab test, so there were no COVID-19 cases within those garages during that trial. There were also no COVID-19 cases within the control garages during the trial. Next slide, please, Sean. So to summarise some of the conclusions from both the data collection and from the working group, high temperatures were extremely rare within garages during that time. So the trial did coincide with a period of low incidence of COVID-19 in London at that time, and obviously some of the measures that Alex has mentioned that garages put in place will have also helped to keep those numbers very, very low during the trial. Participation levels were very, very high, so the garage workforce were generally very happy to undertake temperature testing. So at some garages, actually 100% of drivers took part in the temperature testing. But overall, there was about a 1% refusal rate, so there were a few drivers who weren't comfortable with it. But generally, participation levels were very, very high. Something which helped that was having clear and early communication to staff, discussing the trial, giving people opportunity to ask questions, and also giving a period of familiarisation with the equipment, so that the trial actually ran smoothly. So that was a key factor in maintaining high participation levels. In terms of what technology to use, the garages either used remote scanning technology, so thermal cameras, or they used handheld devices. So the thermal cameras were found to be more easy to integrate within normal sign-on procedures. And after a period of time which did involve some training, both with the drivers and garage staff, they could more or less run by themselves as long as drivers knew what to do in terms of operating them. On the other hand, the handheld devices involved a member of staff wearing PPE and being present for the entire operational duration, which obviously for some garages is 24 hours. So the remote thermal scanning technology was seen to be a more viable option for anyone undertaking temperature testing over the longer term. Next slide, please, Sean. So to summarise some conclusions, very fortunately, there were no COVID-19 cases within the garage. This did mean that we couldn't determine the accuracy of temperature testing. However, we did develop a standardised approach to data collection, which is the kind of thing that will be needed to assess that accuracy. And ideally, that kind of standardised approach would be rolled out not just across bus garages, but across many different industries when people are temperature testing, so that the accuracy of temperature testing can be assessed. There are also some interesting potential behavioural impacts of temperature testing. Does it make people really aware of their symptoms and therefore make them more aware of keeping distance from others and keeping themselves and others safe? Or does temperature testing give people a false sense of security that they are well and therefore do not have to do other distancing behaviours? And that could obviously be problematic because of the potential for asymptomatic spread. So that's an area which wasn't covered in the trial, but is an interesting area for potential future research. Thank you, Sean.
Fantastic. Thank you, Kieran. Okay, so we've seen 2 short presentations there on that first challenge area of COVID, and now what we're going to do is move on to the second one at pace, environmental sustainability. And Doros Nicolaides is going to talk through a number of subtopics in this area. Over to you, Doros.
Thank you very much, Sean. So hello and thank you for joining the webinar. I am Doros and I am a senior consultant on ultra-low emission vehicles and energy at TRL. I work on projects which facilitate the uptake of low carbon technologies in the transport and energy sector. And one of my main areas of interest is decarbonization of the bus and coach sector, which is the subject of my talk today. So many towns, cities and bus operators are looking at their bus operations closely as part of a decarbonization strategy. However, the transitional strategy towards low emission operations is still unclear. There are a number of low emission technologies on the market, and configuration of the system is sensitive to operational factors, such as the routes and operating timetable. There is not a unique technology which meets the needs of all customers today, and this presents significant uncertainty and high levels of business risk, which compromise the wide uptake of low carbon buses and coaches on the roads of the UK. As a consequence, technical and financial modeling tools to support decision making are needed, and this is the subject of the first part of my presentation today. Such tools can be used primarily by bus operators and other key stakeholders, including vehicle makers, infrastructure providers, and local authorities, to decide the optimal choice of low carbon bus fleets for their operations. The second part of my presentation aims to present modeling tools to develop bus drive cycles using data available in the public domain. Such tools can be used primarily by local authorities to understand the performance of a low-emission bus system at the scale of a city or a specific area, without focusing necessarily on individual routes. So next slide, please. So an overview of our simulation and modeling solution is shown on this slide. This is a systematic approach to make recommendations on the technical and commercial feasibility of low emission operations, and it is divided into 5 major parts. The first component of our system is a duty cycle tool, which is used to define the duty cycles of the vehicles performing the route under investigation. Vehicle data, operational data, bus graphs, etc. are used for that purpose, but publicly available data can be used if needed. The tool takes into consideration the slightly different duty cycles of each bus each day, such as the different stop durations at the terminal bus stops during peak and off-peak times. Passenger loading profiles can be considered as well. Once the drive cycles for the vehicles are defined, a vehicle simulator is then used to model the vehicle of interest, and this can be a conventional one, battery, electric, hydrogen, etc. The vehicle models are validated and calibrated using industry-specific tests or operational data if available. TRL investigates the characteristics of the journey, such as the power from the motor, the state of charge of the onboard battery, and the demand for electric heating. The simulation results are used to calculate the energy consumption of the vehicles and to determine operational range. In the third step, the derived duty cycles for all buses are combined with the simulation results to calculate the total energy consumption. The impact of heating and air conditioning are explored as well, and based on the results, tank-to-wheel emissions and well-to-wheel emissions are calculated following the official guidelines. The fourth step in our system determines an appropriate charging infrastructure, which meets the requirements of all vehicle duty cycles. Particular focus is currently given on electric vehicles because they have limited operational range when compared to conventional vehicles or other low emission powertrain options. The options of depot-based charging and opportunity charging are explored, and scheduling changes are proposed if needed. This may include fast charging at the depot during breaks and replacing running empty buses with fully charged vehicles. Depending on the configuration of the system, the new power and demand at the depot or the roadside are determined. And in the end, the economic viability of the proposed scheme is investigated, taking into consideration capital, operating, and maintenance costs. A number of different scenarios can also be developed to perform sensitivity analysis on the results and provide insight about how some key cost drivers might affect the overall strategic decision. And it's worth noting that throughout the entire process, engagement with all relevant stakeholders is maintained to request useful data for the analysis, receive feedback on the progress, and ensure that all technical and operational limitations are taken into consideration. So, next slide, please. So, as mentioned earlier, configuration of a low emission system is sensitive to operating factors, and real drive cycles are needed to perform the analysis that we mentioned. And for that reason, TRL has developed a tool which generates bus drive cycles using information available in the public domain. This minimizes the input needed from the bus operators. The tool initially captures bus route information from online sources to determine basic duty cycles, including information about the length of the trip, duration and speed, average speed between bus stops, and daily mileage on weekdays and weekends. We also get location information about the garage of each bus operator to see the difference between the distance covered by vehicles whilst in service and going from bus stop to bus stop, and the distance covered by vehicles as they enter and leave their routes, also known as dead mileage. The tool can generate any bus duty cycle in the UK. Based on that, the next step was to use the tool to calculate the energy consumption for a low emission bus system on any profile route, and in order to estimate the potential for carbon emission savings. We used average energy consumption figures based on the route characteristics, including the average speed and elevation profile. Then we refined the tool so that it generates drive cycles on a second-by-second basis. So we can run simulations using the vehicle, using the validated models, and produce more accurate results. We are still working on the validation of the tool, but once we are done, we will be able to develop representative drive cycles for any bus route in the UK with no actual data needed from the buses. The tool has interesting applications for local authorities and other relevant stakeholders. For example, it's possible to look for bus routes contributing to the worst air quality hotspots in cities and develop their drive cycles to explore decarbonization options. The tool could also be used to compare different low emission powertrain systems as part of a fleet procurement or management plan, or potentially identify bus routes suitable for electrification, either using overnight battery charging or opportunity charging. And finally, the energy demand and impacts on grid infrastructure can be investigated, assuming that all buses in a city or in a specific area are zero emission. And this is with no data needed from the bus operators. So that's all from me about tools that can be used by stakeholders in the bus and coach sector to support decision making. We are committed to continue working on this important sector with the aim to identify opportunities, minimize uncertainties and risks, and accelerate investment in low carbon solutions. Thank you. And now I will hand you over to Leslie from Humanising Autonomy. Thank you.
Thanks very much, Doris. And yeah, Leslie, over to you on the benefits of modeling passenger behavior.
Great, thank you. Hi, so I'm Leslie. I'm one of the co-founders and the chief product officer at Humanising Autonomy. We're a predictive AI company that is trying to create the global standard for human interaction with automated systems while preserving privacy. So while our technology is usually embedded on vehicles, such as for warning bus drivers, or embedded on roadside units so that we can inform intelligent traffic systems, we quickly realized when the COVID crisis started evolving that we could use the same technology to understand social distancing. So on to the next slide, please. What we were able to do with Transport for Greater Manchester is that we were able to take the existing CCTV cameras that were placed in the station and then analyze the level of social distancing within those environments. This was all done in a privacy-preserving manner. So it was able to analyze exactly the distances between the different people at different times in different locations and provide us with hotspots of where there was a lack of social distancing. Not only did that give us insight in the risk level of certain areas in the city, but it was also allowing them to better arrange the public space to prevent non-social distancing. Because we were able to perform this analysis in real time, we were able to also experiment with how we would design passenger flows, how we would improve the information that was displayed to the commuters, and how that impacted social distancing. So while that was very helpful in preventing a lack of social distancing, it also allowed Transport for Greater Manchester to have a better understanding of how passengers were using these hubs. So by understanding where people were dwelling, where more people were using certain areas or corridors of walking, they were able to segment the flows of people throughout the stations, provide signs on the floor to inform them, and even use real-time understanding of social distancing on the TVs to inform them about the percentage of social distancing what that was happening to influence how they would socially distance in the future. An additional benefit was that it also provided information about how people were using the bus stands. So now they had an accurate count of how many passengers were using certain bus stands at what times of day, so that it was able to better design the not only the routes of the buses, but also the timetables that they were driving on. Additional to that, there was also future urban planning considerations. By understanding how certain people were using entrances, also outdoors, whether people were following the crosswalks or the further infrastructure, they were able to decide how in the future it would be better to design more efficient transportation systems within the stations and outside of the stations. So I'm happy to answer any further questions in the question time after these presentations. And now I'd like to introduce Dr. Cooper, who will talk about passengers and mental health impact of COVID-19.
Great, Ali, over to you.
Brilliant, thanks, Sean. Okay, I'm going to first set a bit of context for a study that we've done very recently, which is looking at the impact of COVID-19 on the mental health of people with severe anxiety, and is looking at the implications for public transport and how to increase confidence of people returning. Then I'm going to talk to you a tiny bit about the kind of, not about the results, but about some of the research and how that helps us see these environments through the eyes of somebody who might have severe anxiety, and then to think about what the implications are in terms of actually helping people come back. Okay, Sean, if you go to the next slide, please. So firstly, some important context. So outside of a sort of pandemic time, research shows that about 10% of people in the general population have some form of anxiety. And our previous work here showed that actually people with anxiety and other mental health problems actively avoid public transport and they choose other modes. Some recent research around COVID-19 and also during other pandemics shows that the incidence of a severe anxiety in the general population increases to about 20 to 30%. So it is a significant amount of people. And also people who have mental health problems are also more severely affected by the pandemic. We think this is important to you because I guess the pandemic has had a significant impact on the bus sector, and it's really important to help build confidence in people returning, especially people who feel anxious about public transport, and how to make it more, I guess, more accessible. So we set about to try and find out how you could do that through a DfT-funded research project, which combined, I guess, looking at research evidence Also looking at models of why people get anxious during pandemics, using some particular sort of clinical experience with our project team. And also we interviewed people who have severe anxiety and were either avoiding public transport or who were currently using public transport. Okay, next slide, please, Sean. So we feel there's real value in trying to see the world from sort of other people's perspectives. And that's one of the really good things about doing sort of qualitative research, because I guess looking through the world from people's perspectives, we can try and think about how to help people more easily. So we can't talk directly about the results because it hasn't been published yet, but we can certainly talk to you about some of our research findings and I guess some of our views. So there's three important, I guess, concepts really to consider that we think it's really important. So the first one is that people who have anxiety difficulties, they often struggle to cope with situations that appear ambiguous or that appear uncertain. So when you're anxious, you have a strong desire for, I guess, environments to be predictable. So people tend to worry and they predict and they think about worst case scenarios. So people might have a very different view about what it might be like at a bus stop at the moment, or they might imagine, I guess, a scene like this, or they might imagine scenes that are worse than this. So really it's about how can we provide some really good evidence to help people know what to expect. If you go to the next picture, Sean, please. The next one is, I guess, an anxious mind needs some concrete proof to lower anxiety. So where this picture can provide a lot of reassurance because it shows that actually bus operators are taking this very seriously. But how often does it happen? How often do the public transport staff follow the rules of cleaning, and also how are they supervised? So how can people know that this is happening and that it's being done properly? The next picture, please, Sean. So the next thing to think about is that often, I guess, when you're anxious, we tend to look for information that confirms an anxious view of the world, and people are very vigilant to sources of threat. So, for example, in this picture, people are wearing masks, but do they realise how close they're standing? They're standing, to each other. Even though people are wearing masks, that might be the thing that people really focus on. Also, I guess the one person not wearing a mask might outweigh the 100 people that are wearing masks. And the one public transport staff operator not wearing a mask properly might outweigh thousands of people wearing their mask properly. So these kind of things we feel is really important to sort of consider. So if we go to the next slide, so what we're doing at the moment is we're looking at our results, and we're developing a framework that will enable public transport operators and also policymakers to test their measures to see how it might instill confidence in people with severe anxiety. We can't share this at the moment directly, but we can certainly share some important factors to consider. So the first one is, how can you help people get a sense of certainty about public transport environments? And our next speaker, Boris, will touch on how good quality data that's reliable and transparent and trustworthy can really help that. We know that people get more anxious when they perceive that other people aren't taking the situation seriously. So how can you, as a public transport operator, demonstrate that and show that you're taking the risk seriously? So this might be about good design, it might be about the training of staff, or it might be sharing the amount of research and the amount of effort that you're taking to actually reduce risks on public transport. Finally, we know anyway, and also people that are anxious know that there's no difference, that actually people perceive the risks very differently. So there's some people in society who actually minimize the risks, and there's some people that maybe overestimate the risk. So how can measures actually accommodate that variance? Is there a way to design the environment that make sure people have to follow the rules as opposed to a choice? So the next slide really is just about next steps and the type of work that we would like to do and we think is valuable. So we know that there are other hard to reach populations who are actually really affected by the pandemic. So the research says that actually teenagers are very affected, and also other people with mental health problems. We want to develop, I guess, methods and processes to engage the public and especially vulnerable members of the public to test their views of measures to sort of keep this sort of work going. We see it as very valuable. And finally, we think that the staff, that public transport staff have a major role in sort of instilling confidence. So how can staff be engaged? How can we think about the culture in teams and within organisations to really support, you know, the sort of implementation of measures? I'm going to hand you back to Sean. Thank you.
Thanks very much. Thanks very much, Ali. And now we'll just move on to our final presentation from Boris Butt. Over to you, Boris.
Well, thank you, Sean. Boris Butt here, transport economist at TRL. And I just want to follow up on Leslie's and Ali's narratives from a data and behavioral economics perspective. The key challenges that I would like to discuss are what is the demand picture? How do we monitor it? And how do we communicate that confidence for, as Ali was saying, for people to get back onto buses where possible? Next slide, please, Sean. And I would want to start with something that you won't be unfamiliar with. On the left, we can see that since the lockdown in March, cycling emerged as a popular means of transport, with car trips recovering to almost pre-COVID levels in September, October. On the right, we see a more reflective picture of public transport, whereas April saw public transport modes down to under 20% their usual demand. The recovery is more two-speed. Rail and the London Underground are hovering around a third compared to buses seeing over half of their passengers returning. There is an imminent piece of work that I've been leading on in-house at TRL, capturing some of these monitoring issues, and I'm happy to share if anyone's interested when it's complete. But what are some of the issues behind the trends that we are seeing? Next slide, please, Sean. First, there is a lack of standardized APIs from which we can extract a huge amount of data. That means in some cases, your code would need to extract information from PDFs, which is far from ideal. The second problem is a lack of data sources. And what that means is there are often conflicting levels of granularities, geographical boundaries and methodologies. Google, for instance, is able to aggregate mobile signals to produce what they call community reports, but its public transport trend doesn't tell you anything about trains or buses. And on the right, can we make it more forward-looking? Are government restrictions and or COVID cases a good indicator for demand trend? We can explore the econometrics of these series, and any trend indication on either a macro or local level will be immensely helpful to transport planners and service providers. Next slide, please. Sean, thank you. But the solution to much of this actually rests with many of you who've joined today. We have seen government data on different levels in different forms. Google and Apple pull their data sources together, and the Transport Technology Forum actually collates local authority data. But what would really help us to help you is actually the operators' data. And I'll explain why this is the case, both for operational purposes and to address some of the anxiety issues that Ali touched on. So next slide, please, Sean. Thank you. Because if we have that data, we can create a dashboard like this. this will be helpful both to service providers and passengers alike. It could be built into transport apps, and could certainly sit on the operator's web page. So in this example dashboard, a passenger thinking of taking a bus can look at what the demand has been. So I've taken a national example, but this can be refined down to a local level. A forecast can be incorporated as well if we can be forward-looking, together with the safety measures in the middle, indications of how much space each passenger can have. So that's just touching on Leslie's and Ali's point. How many times the buses are cleaned each day? These are the things that build the confidence, or build back the confidence of passengers, to encourage them to get back onto buses where they can. So bringing this foresight to another level, what is the local picture? What are the COVID stats in your area? So these are just reinforcing the message that we're there for you if you are ready to travel, to alert you and inform you. So for your bus route, when is the best time to ride? When is the best time to avoid? If we can communicate this, we can position ourselves ready for people to get back onto buses safely. So I'll hand back to Sean for, I think, questions, conclusions, answers.
Thanks very much, Boris. Yeah, so fantastic. So those are the presentations complete. One thing that I was struck by as I was listening to that is the sort of breadth of evidence that we appear to be able to bring to bear on solving some of these issues, and there are some real contrasts in there that struck me. So the contrast between, for example, the detailed analysis of microscopic environments and things like airflows, all the way up to the modeling of the kind of data that Boris and Doris were talking about. There's also a sort of contrast for me in terms of buses. I think we all think buses have a pretty old technology, a fairly old proven idea, but look at the new technologies that are being used to add value there. So some of the stuff that Leslie was talking about, for example, using AI and machine learning to understand passenger movements. And there's also that kind of contrast that we always see, I think, in transport and in public life around, technology heavy implementations, but also needing to account for the human component within that, and certainly mental health is about as human as it gets. So what I'd like to do now is invite some question, well, ask some questions. We have had some questions through, which I'll just quickly run through now, and I'd encourage people on the call, please, to again email them to Alex at the email address on this slide, or just pop them in the chat. We have had a few already. The first one is a general one which I can answer, and that was somebody has asked whether the slides can be made available. I think what we are going to be doing is make the recording of the webinar available later today. I don't know if Penny needs to add any detail to that, but I think we'll just email it out to you, or communicate that to you in some way. What I'd like to do now is try to make sure that we have at least one question per speaker. So I'm actually going to ask the first one of Kieran. So we've had a question on temperature testing. With all of the national testing we've seen, do we now have a clearer picture of the percentage of asymptomatic cases, and any further information on how easily asymptomatic cases can pass on the virus? And the reason for that is it will obviously help the bus industry make decisions on whether to roll that out. So over to you.
Yeah, absolutely. No, it's a really, really good and really, really difficult question. So back in April, the rate of asymptomatic cases was estimated between 5 and 80%. So that's a very, very large range. So there's a huge amount of uncertainty. Unfortunately, and the more recent data has actually been high, and in one case even higher than that. So a paper that came out the other day from UCL estimated asymptomatic cases at 86% of positive test cases. Whether asymptomatic individuals can pass on COVID-19 is to the same extent as symptomatic individuals is a different question. But given that they have the markers, the epidemiologists are assuming that asymptomatic spread can happen. And there's other studies which show that asymptomatic individuals have a similar viral load, which indicates that they can spread through droplet transmission just through talking. So it's unfortunately it is viewed to be a very significant factor, although the exact level isn't known. The other issue with temperature testing is that fever itself isn't present in every symptomatic individual. So I think the estimates for that range, I'm just going to look at my notes so that I don't get it wrong. At the time that we looked at this, they range between about 50% and 78% of people who have COVID-19 symptoms have a high temperature. So that means that between 30 and 50% of people with COVID symptoms don't. So temperature testing is a fairly crude measure of COVID-19. That doesn't mean it doesn't have value, particularly when combined with lots of other measures. So I'm afraid, unfortunately, the science doesn't give a very clear answer, but it certainly offers some challenging factors to do with COVID-19.
Fantastic. Thank you, Kieran. As we go through these questions, I suggest if the person whose question I've read out wants to put their hand up to have a discussion about the answer, they're welcome to. I'm not seeing anybody do that now, so I'll move on to a question I think for Alex. And I think this is a fairly obvious but really important question. The work obviously you've done, Alex, is focused on protecting drivers who have assault screens in front of them. What about all the buses and coaches that don't have assault screens? What do we do for them?
Well, that obviously is a bit hard to look at. The focus is always on having good cleaning regimes and having fresh air circulating, because that's the backbone of the protection against the virus, and that's following the government advice. I suppose depending on the vehicle, it might be possible to install screens. It would have to be considered on a model by model basis, and it just depends on how they're built and what structures are available to build from. That obviously is a very challenging proposition. So operators and such may not find that feasible. It just may not be feasible, unfortunately. I think the important point that TfL found was to build it into their specification for new vehicles. So that, I think, would be my recommendation, is to think about that for other types of vehicle for the future. Because COVID may be with us for a long time, or other variations of coughs and sneezes. And of course, if you can keep even common coughs and colds away, then that's going to help with reducing sickness levels overall, and should be beneficial. But yeah, fundamentally, the most important things are really good cleaning regimes and getting the fresh air circulating.
Yeah, thank you, Alex. I mean, that's a good point, isn't it? COVID has brought this to a head, but I guess I'm not sure what work has been done to show what the impact of communicable diseases has been in general on public transport, but I'm guessing that's a real issue. Thank you for that. So I'm going to take the chair's opportunity to ask a question of Doros. At the beginning, Doros, we talked about the sort of dual side of the environmental sustainability issue, which is the sort of, saving carbon, but also thinking about air quality locally. And I just wondered if you have a feel for which of those is driving or is the main driver for low emission buses. Is it saving the planet, or is it saving public health, or is it both?
At the moment, I think it's a combination of both. But I tend to believe that the political agenda to reduce greenhouse gases emissions and climate change is the main driver for decarbonizing bus operations. And this is mainly because due to the fact that a number of low emission zones have been proposed and introduced around the UK, but the air quality standards which are demanded by those low emission bus zones are met by Euro 6 vehicles, so conventional vehicles. So air quality alone doesn't push the boundaries for further improvements in and for further introduction of low emission vehicles. And I think this is something important to note, because if we want both greenhouse gases emissions and air quality to drive decarbonization of the bus and coach sector, then possibly more strict regulations will be needed.
Okay, thanks, Doris, for that. A question for Leslie. Just wondering about the approach that you use at HA. It seems to be based on CCTV or camera-based analysis. What are the opportunities to use similar approaches in areas that don't have coverage of CCTV? Are there other things, other data sources you're thinking of using?
We're not. We will need camera footage to be able to perform our analysis. Luckily, the UK has a widespread coverage of CCTV cameras.
Let me rephrase the question then. And what are the other data sources that you think may be able to complement your approach?
Obviously, there's the counting of people buying tickets at the station, people passing the gates. So those are relevant. I think are relevant. One thing that is interesting is our cameras on vehicles. So we also have these technologies deployed on vehicles driven by people, which allows us to create kind of like a heat map of a kind of GPS locations of densities of people. So while these aren't CCTV cameras that are placed in infrastructure, they are cameras that are placed in the buses, which allow you to not only understand social distancing within the bus, but also social distancing out around the bus in the environment that the bus is driving through. So I think those are interesting sources of data that we could use additionally to roadside unit cameras or station CCTV cameras.
Okay, fantastic. So we have had some more questions for Alex, I noticed, but I'm going to just continue to make sure that we get coverage from all of the presenters, and then we'll come back to those. And again, people, please still send through questions in the chat, even if they're for people who have answered already. The next question is for Ali, and this question is, I think it's about what the bus operators can do to, so the question is worded, what kind of examples can you give that might show we, the bus operators, are taking safety seriously? So what is it that people are looking out for to be reassured specifically?
Okay, thanks. That's a good question. So I think one area is I guess the design of measures and how they're kind of implemented. So I guess, for example, designing this might not be exactly, I guess, relevant to buses, but I think the principles are the same. So designing a kind of a one-way system within a transport hub, sort of using a push door might be perceived as being safer than a pull door because people perceive there's less contact patches. So trying to kind of engineer doors to go that way shows, I guess, will instill some confidence in design, and it kind of enforces this idea that these measures are actually being really thought about. It isn't just about saying let's have a one-way system, but let's design it in the best way that we can. Having I guess having a door with a foot pedal as opposed to any kind of contact patch would then increase, I guess, confidence still. So kind of, I guess the design of measures is really key. You can say the same about seats, I guess, using segmented seats. So the impact of a sign on a seat. So let's say, for example, a sticker or like a covering, might not provide as much confidence as an actual physical barrier, where someone has really put thought into the design about how actually people have to comply, and it provides confidence, I guess, that the transport operator is serious about thinking about measures and actually investing in measures.
Okay, and I'm guessing then for some of the softer things you were talking about, like mask wearing and cleaning, it's about making that more visible and visibly enforced as well. So it's not just about design of infrastructure, but also that sort of softer stuff as well. Would that be fair?
Yeah, that would be very fair. So it's also things like behaviour of transport staff, helping transport staff be on board with this is how we as an organisation are thinking about risk, and helping staff realise that they're the outward face of the organisation, and this is how we do safety. So those kind of softer skills, can really, demonstrate seriousness.
Cool. Thank you very much. The final speaker who has not yet answered one rather, is Boris. So Boris, there's one for you here. Says, from an operator's perspective, being able to forward look is valuable. How can we establish forecasts a week or 2 weeks out from now?
Yeah, thank you, Sean. That is an important question. So when we think about forward looking, what are the factors or what are the ways that we can do this in a robust way? One of the ways that we can do that, certainly by applying econometric techniques, is something called auto-regressive integrated moving average modeling technique. Is heavily used for time series estimation. So it takes into account, for instance, in the last 2 weeks, what were the demand picture, certainly locally, and we would then expect that future demand for the next week out, for instance, would be some kind of coefficient, so maybe 80% of last week's demand plus some kind of what we call moving average in terms of the error term, the part that we can't explain. But there's certainly other things that we should be considering, and they are very relevant, including, as we just saw, I think yesterday, the 3-tier system in England in terms of COVID restrictions, COVID cases, hospital admissions figures. I think these are things that we can certainly gather and harvest and apply some sort of a dummy variable to say if the number of cases hits a certain threshold, then we can expect, as we saw, I think, in the first slide that I was showing, in October, September, figures were starting to taper off as the recovery journey continues. So I think these are the things that we can certainly take into account for either a time series estimation or a panel approach. So certainly that would be improving our 1 week, 2 week forecasting ability.
Okay, so the answer is we can do it. It involves some fairly robust modelling, but it can be done, we think. Cool. Okay, so I'm going to go back to Alex now. There's a sort of detailed question here about screens, I think. So what's the process of adapting the bus to given design recommendations? How long does it take? What's the impact on operations for the operators? What's the perception of drivers, and how many operators have adopted these? That's about 4 or 5 questions there, but all roughly about the same. Basically, how do we do this? What is it like? Yeah.
So I will try and give a brief summary. I think it was a case of literally walking around each bus model in the fleet and having a look at where the gaps were, and then the operators would source some plastic screen paneling and various materials and try and build templates to see if that would fit, and they would try each solution out per model. And then if it worked and they got to less than a 5 mil gap or closer, then they would roll that across, the set of models they had. Obviously, the mix that each operator had, they might have only 2 models on their fleet, that's fairly unlikely. It was more likely lots of different variations. So it was quite a complex process. Again, depending on the size of the fleet, you know, if they've got a lot of buses to convert, then it took them longer. I would say it was a few weeks for most of them in the London fleet, maybe up to a couple of months for the biggest operator. Obviously, those conversions of the assault screens were happening during the lockdown period. So the numbers of buses on the road had reduced anyway. There weren't as many going out on shift. So they were able to kind of more conveniently do it. I think it might be more challenging now. Now the service levels have gone back up a bit. I think it went down pretty well with the drivers, and you know, obviously the operators had feedback along the way, and then definitely all of the London operators have implemented that, and I know they've also been spreading the message out to their different regions as well through the UK to consider adopting. I wonder maybe if John Erdley is still on the line, if I could maybe ask him to add any more to that, and I'm hoping that I've kind of summarised it, but John,
yeah,
if you're there.
I think it's a good summary of that, and I think you're right. It was probably made easier to, once those first templates are made up, I think it was easier to sort of move through the fleet and fit, and the fact that we were down to 87% of normal PVR, so peak vehicle requirement. So we did have more vehicles to fit out in the day. I think where it was challenging was that everyone was trying to do the same thing at the same time, and obviously we were competing with the likes of supermarkets and other sectors for the same polycarbonates, the same plastics and the same materials. So it certainly most, if not all, operators had a mixture of permanent solutions from at first fit, but lots of temporary solutions made up of, you know, I think my Amazon account, I was buying that much Gorilla Tape from Amazon at the time. So I think we were all making up sort of as many high quality temporary repairs as we could.
Yeah.
And but then going back over them to second fit to just finish off with polycarbonate and other materials then. So yeah, I think it was a good summary. A good summary. And obviously each of those designs, each of us in our own ways, we checked off against with local trade union reps to make sure that they were comfortable, and then it was done at the next level, at convener level, then per operator. So I think it was handled really well between each of the operators. It might have been slightly different, but I think we all got the same result really. So yeah, it was a good process.
Yeah, thank you very much, John. Thank you.
Fantastic. So I think unless there are any final pressing questions, we've had good coverage there. So thank you for people who contributed. And I believe we have now reached approximately the end of where we thought we'd finish. So with that in mind, nobody else is putting their hand up to ask any final questions. So I think we will end the webinar there. Thank you very much for coming, everyone. And just any feedback that you have on the format, length, type of presentations would be gratefully received. If you have any of that, please email Alex at the address there on the slide. Thank you so much. So we will now finish the webinar, and yeah, thank you all. Enjoy the rest of your days. Thank you.
Thank you, everyone.
Thanks for having us, Sean.
Bye.
Thanks.
Bye-bye.